Okay, so you need this sheet that I gave out today in class. And notice on the top it talks about the center of mass. We mentioned it yesterday in class. So the center of mass of an object is it's like the balance point on the object. It's the point where if you put your finger, you could support the weight of the object. Every object has a center of mass. If the object's uniform, it's going to be exactly in the middle. If it's not a uniform, like you and me, it won't be exactly in our middle, but we still have one. For this weekend, the ones you're going to do, the teeter-totters or seesaws, the board of the seesaw is the thing that all the forces are going to be acting on. And because it's not a point object, because it has dimensions, we have to take into account its weight. It's a force that's acting on the board. The seesaw or teeter-totters boards are going to be uniform, so they're going to be halfway along the length. Okay? So if you look at the first example on this sheet, it says two children are sitting on a seesaw of length 5 meters with a mass of 10 kilograms. The seesaw is perfectly balanced on a fulcrum placed at the middle of the length. So you should draw it to start with, okay? So we draw our seesaw. And then you're going to put in the fulcrum. And then you're going to put in all the forces that are acting on the seesaw. So there's one object out here, and so there's a force acting down. And there's another object at the other end, and so there's a force acting down. And both of these forces are the weights of the two children. Okay, so Fg1 and Fg2. But there's also a weight of the seesaw, and because it's uniform, it's acting smack dab in the middle, Fg of the board. And then, of course, the fulcrum must be putting a force upward on the board, because if it wasn't, the whole thing would fall to the ground. So we could call this FUL for fulcrum. Okay? So now it says one child is mass 46 kilograms. So M1 equals 46 kgs. And is 2.2 meters from the fulcrum. So R1 is 2.2 meters. The second child is 1.8 meters. So this is M2. And it doesn't tell us how much they are, but it tells us R2 is 1.8 meters from the fulcrum. And it wants to know what must be the mass of the second child. And so the board is perfectly balanced. And what that means, let me make this a little bigger. What that means is that the sum of the torques must equal 0. And so what are their torques from? Well, there's a torque from person 1. There's a torque from person 2. Oops, ignore that positive sign. There's a torque from the fulcrum. And there's a torque from the weight of the board. And all together, they must equal 0. So I said ignore the positive sign. That was a habit, because you need to figure out which ones are positive and which ones are negative. And the way you do that is you take your writing utensil and you hold it at the pivot point, and you see which way the forces are going to cause the writing utensil. Notice my coloring book underneath. That has absolutely no pages colored in it, by the way. Which way the force is going to make the writing utensil rotate. So if I hold my pen right along the board and at the pivot point, Fg1 is going to make it rotate this way, which is counterclockwise, which is positive. Fg2 over here on this side is going to make it rotate clockwise, which will be negative. That's why I told you to ignore the positive sign. This one will be positive. This one will actually be negative. Now, what about F of the fulcrum and Fg of the board? Well, our pivot point is right here at the fulcrum. So these two are actually both going to go to 0. And they're going to go to 0 because there's no R for them. Remember, torque is RF sine theta. Well, the R is 0 because the R is the distance from the line of action of the force to the pivot point, and for these two forces they go through the pivot point, so R would be 0, so those disappear. So all we are left with then is R1 FG1 sine theta 1 minus R2 FG2 sine theta 2, and that has to equal 0. Look at the angles between the R, which is along here, and the F. It's 90 degrees. So sine of 90 in both cases will be 1. And so we're going to have R1 M1G minus R2 M2G equals 0. The G's will cancel. And you're solving for M2, so take it to the other side. R1 M1 is equal to R2 M2. To get M2 alone, divide by R1, or M2, excuse me. No, divide by R2. M2 will equal R1 M1 over R2. Fill in your numbers. M2 will equal 2.2 meters times, what was it? 46 kilograms over 1.8 meters. And then get your value for M2. So let's see, 1.1 over 0.9. One should do this in one's head. But I typed it in the calculator. I think it's 56.22 kilograms. But of course, I'm a little rusty with my calculator. Okay, so that's all you do. So for the 3 questions on the sheet, they're all teeter-totter. Do the sum of the torques, solve for the unknown. The 2 in the textbook are actually really pathetically simple. You don't even have to do the sum of the torques. You just find the torque given the info. Okay? Don't worry about example 2 and example 3 on the back. We'll do those on Monday. They're totally different and they'll be tougher. All right, so try those 5 questions. Have a good weekend. See you Monday.